So as I told you already, you can use Lami's theorem in the case of three vectors which form the sides of a triangle. So in the last example, we discussed about forces that act at a point and keeps the object in equilibrium. Here there are two jets, jet A and jet B. And what is the condition given? Let us try to visualize it. And jet A is flying east. Suppose if this is northeast atlas notation, if you take up, so jet A is flying east this way, but jet B is actually flying 45 degree north of east. So this way it is flying exactly 45 degree. But to jet A, because the fellow green is jet A, let me do that, this fellow is jet A, or we will call it velocity of A, and this one is velocity of B. What is velocity? But for jet A, the velocity of B is actually 60 degree. That means it seems to be like this at 60 degree. This is velocity of B with respect to A. It is 60 degree like that. So what is relative velocity? You already know that relative velocity of B with respect to A is VB minus VA. So what we are supposed to do is you have to just change the direction of this. Then let us cut that. Then instead of doing this, I will just copy this diagram. Just wait. So how we need to proceed with this. So relative velocity of B with respect to A means velocity of B as observed from A is VB minus VA. For that, what we are supposed to do, we have to do VB minus VA. Then in order to make VA minus, we have to give it a 180 degree rotation. So let's give 180 degree rotation. Okay, now it is exactly opposite to that. So this is minus VA because we have changed the direction, so it is minus VA. Now VB minus VA means from the tail of this to the head of this. What we are supposed to do then, this is velocity as observed by A. This is actually, I shouldn't be rotating, it will be like this. Okay, so this is what VBA, this is what velocity of B with respect to A. Now you know the angles, right? So this is actually 45 degree and this is actually 60 degree, and you know this is 45 and 60, obviously this angle is 75. So the question they are asking is like jet A is going towards east, jet B is actually 45 degree north of east, and the velocity as observed by A is, it is going away at 60 degree from it. So now this velocity A, velocity B, velocity VBA, relative velocity, all form the sides of a triangle. Then you can easily apply Lami's theorem. So according to Lami's theorem, now it is velocity, the modulus, so VA by sine 75 degree equal to VB by sine 60 degree equal to velocity of B with respect to A is sine 45 degree. What you already know is only the velocity of A. So the velocity of A, so I'll have to calculate this. So you just need to find out like what is relative velocity, what is the actual velocity, anything you can find using this. If you compare these two, the actual velocity of B you will get. Velocity of A they have given 800 km/h, and by sine 75 is somewhere between √3/2 and 1, which will be equal to velocity, actual velocity of B by sine 60 degree. Sine 60 degree is √3/2. This will be little more than √3/2. So little more than √3/2 by little more than √3/2 will have value little less than that. So approximately I have calculated. So VB equal to 800 into √3/2 by sine 75 degree, which will be approximately 717 kilometer per hour. And you obviously know that because this is 800, and when this VA is going this way, BB is going this way. If its velocity is more than this, it appears to be going either this way or this way. Because it is receding at 60 degree, you obviously know that it is actually like its velocity is less than that of this. So we have found out. If they ask you what is the velocity of relative velocity of B with respect to A, so it is VBA equal to sine 45 degree by sine 60 degree. I am basically comparing these two right now, or you can compare VBA with VA also, into velocity of B, which is 717 kilometer per hour, which we have right now find out. I hope this example would help you to apply this in ways that you have not done previously. In most of the relative velocity concepts, if you use Lami's theorem, that is of great use. In fact, you can avoid so many confusions.